Problems 17 through 24 all use this picture over here off to the right. Something that I want you to take note of right here at the beginning because it will become important later on as we're looking through these problems. Bless you. It says right here that ray OD is a bisector of angle MOL. Ray AD is a bisector of angle MOL. We will need that later. Number 17 says name a ray containing point F. Well, point F is over here. It's okay. If we're going to name a ray, we need to stay on the same line. Here's the line that contains point F. What other points are on that line? E. E is the only other point on that line. So we could name ray EF. That would contain point F. Ray EF would start at E and go forever in this direction. A ray has an end point, so a spot with no arrow would stop right here, but it would go forever that direction. A ray has an end point, and then it goes forever in one direction. This is ray EF. There is another ray that I could name that contains point F, and that's if I started at F and we went this direction. That would be ray FE. Now, one of the things I want you guys to notice is even though this ray points to the left, on my notation, the arrow still points to the right. The end point goes first, and then over here is the point in the same direction as the arrow. But the notation over the top is always an arrow that points to the right. All right. Number 18. Something is upside down capital T, line PQ. Does anybody remember what this upside down capital T means? It means perpendicular. That's absolutely correct. And what does perpendicular mean? It means that it makes right angles or 90-degree angles. So we know that one of those lines is PQ because they said that in the problem. We want to know PQ and what else are perpendicular. Do you guys see any right angle markings on the picture anywhere? Yep. Right here at point O, there's a right angle marking. It touches line PQ, but then it also touches what other line? CD or OD. You could call that line CD or line OD. So CD with the line notation over the top, or you could call it line OD. OD with our line notation over the top. All right. Number 19, the measurement of angle PON. Well, P is up here, O is right here, and N is down here. So this is the angle that we are trying to find the size of. This angle right here. Right next to it, I see an angle that tells me how big it is. How big is the angle right next to it? 37 degrees. These two angles share this side, and together their non-shared sides form this straight line right here. What do we call the special angle pair that shares a side and their non-shared sides make a line? Dan. They're not called vertical, but you're close. You're in the right territory. Adjacent? They are adjacent, but they're even more special than adjacent. They're a linear pair. Adjacent angles just means they share a side, so these are adjacent. But what we're after here is that they are a linear pair. They form this straight line together. This is absolutely vital that you guys learn how to recognize vertical angles and linear pair angles because they have very special relationships that we won't stop talking about until May next year. Because together they form a straight line, that means they add up to how much? 180. Linear pair angles are supplementary. They add up to 180. So the measurement of angle PON plus 37 degrees equals 180. Then I can subtract 37 from both sides. What is 180 minus 37? 143. So the measurement of angle PON is 143 degrees. The very next question says, name a linear pair. We have identified a linear pair right here. And so we just need to name these two angles. One of them is angle PON. Angle PON. That's the one in orange. What's the name of the angle that's there in blue that's the linear pair? What is the name of the blue angle? Has to be 3 letters. POM. Angle POM. Or could you do MOP? As long as O stays in the middle and you have the same 2 letters, they can be flipped around the other way. But the middle letter has to stay in the middle. All right, angle NOQ is the next one that we want. Angle NOQ is this one right down here. Let's come back and look at this 37-degree angle. Because these two angles have a very special relationship. This is another one of our specially named pairs. Those are vertical angles. And what's the relationship between 2 vertical angles? They are congruent. So if the one up on top, POM, is 37 degrees, how big is NOQ? 37 degrees. Vertical angles are congruent. Linear pair angles are supplementary. Number 22, name an angle containing point K. It can be any angle we want as long as it contains this point up here. Can somebody give me one angle that contains point K? KOP would be one angle that contains point K. There's a lot of possible correct right answers for this one. But KOP would absolutely be an angle that contains point K. All right. Next one we want is the measurement of angle POC. Here's P, here's O, here's C. We want to know how big that angle is. How big is that angle? It is 90 degrees. Are we guessing at that or do we know that? We know it. How do we know it? Yes, because we said that PQ and CD were perpendicular. So all 4 corners that are made from those 2 lines crossing are right angles. We have the right angle mark over here. This one would also be a right angle. This would be a right angle. And this would be a right angle. We have 4 right angles surrounding perpendicular lines. There will always be 4 right angles when we have perpendicular lines crossing. Yes. I think you are right. All right, number 24 says, name and mark on the figure all angles congruent with angle LOD. Go ahead and come up here, yes? Write your name, date, and time on here, and then put this marker back in here. All right, angle LOD. Let's go find angle LOD first. Here's angle LOD. Now, what is one of the special angle pairs that would have to be the same size as this? What would be the name of the special angle pair? Vertical angles. Vertical angles are congruent. They have to be on opposite sides of an X. So what I'm going to do is I'm going to follow these lines in the opposite direction. So from O, instead of going this way, I'm going to go this way. Instead of going towards L, from O out to L, I'm going to go backwards towards K. That angle right there is the vertical angle to LOD. And we know that vertical angles are congruent. So this angle would be the same size as this angle. What is the angle that we have marked in blue? KOC. Angle KOC, or COK, that would be fine. All right. There are more angles, and this is where we have to go back to this information. It said that ray OD, that's this right here, is bisecting angle MOL. This angle right here. What does it mean to be bisected? Cut in half, yes, split into two equal parts. So what other angle would have to be the same size as this if the light blue one was cut in half? MOD, this angle right here. Angle MOD would have to be the same size. So angle MOD. Angle MOD has a vertical angle that goes with it. Can you guys help me find that vertical angle? CON or NOC, this one right down here. CON or NOC. Angle CON. Nice job. What else would you guys like to look at from the review? Yes, Dan? 1 through 5? Absolutely. So we're going to go to the front page. Problems 1 through 5. All right, so my screen is a little weird. Let me see if I can zoom in. I don't know how well I can do this, but I'm going to try my best. All right, I don't know how well I can write on it like this, but I'm going to try. What angle is formed by ray XY? Here's ray XY. And ray XZ. Here's ray XZ. What would be the name of that angle? Can't call it XYZ. We could call it YXZ. Yep, we can call it YXZ. Remember, the corner of the angle has to be in the middle of the name of the angle. Where you make the turn on the angle has to be in the center of the angle name. What's another name we could give to that exact same angle? We could call it ZXY. Angle ZXY. What's another name we could give to that angle? Are there any other points on that angle? We can call it angle 1, absolutely. When there is a number tucked back into the corner, we can name it with the number. So we can call it angle 1. Are there any other points on the pink angle? V is also on there. So instead of calling it YXZ, we could call it VXZ. Angle VXZ. And if I can call it VXZ, what else could I call it? ZXV. Angle ZXV would also work. All right. Number 2 says, name the vertex of angle 3. The vertex is the corner. Here's angle 3. Thank you. What is the name of the corner of angle 3? Z. Daniel? Yes. Okay. If we have time, I don't know that we'll have time. Daniel had asked me before class started. Vertex is the corner of an angle. The vertex is the corner of the angle. I need you to write your name, date, and time on here, and then put the marker in here. What are all the possible names for angle 4? Let's go find angle 4. Here's angle 4. What is one possible name we could give to that angle? What is one possible name we could give to that angle? X, Y, W. That would absolutely work. Angle X, Y, W. If I can call it XYW, what else could I call it? I could call it XYZ. Angle XYZ. Instead of going all the way to W, we could stop at Z. Let me see if I can write that a little clearer. All right. With either one of those names, what could I do with the letters? I can switch them around. So we could do WYX, or we could do ZYX. Are there any other points other than X, Y, Z, and W on that angle? V is also on that angle. So we could do VYW. Or we could do VYZ. VYW or VYZ. And what could I do with both of those? I can switch them around. I can flip the letters around. WYV or ZYV. What is another name for angle XZY? X, then over to Z, then up to Y. What's another name I could give that angle? We can call it angle 2, or I heard somebody telling me another name. YZX. Angle YZX. Last one here is asking us to name the sides of angle 2. So once again, we're going to look at angle 2. This is one of the sides of angle 2. What would the name of that side be? XZ. It is a segment because there is not an arrow over where X is. Z has to be an endpoint because it's the turning point of the angle. If there was an arrow where X is, then I would call it a ray. But there's not an arrow where X is, so it's a segment. So either segment XZ or segment ZX. You could do either one of those for this side right here. And we need the other side. What can we call this side over here? ZY. Segment ZY, or you could do YZ. All right, what else would you guys like to see? Yes. Number 6? Absolutely, we can do number 6. There we go. Now this should be a little bit easier. In the figure, ray TP and TS are opposite rays. Ray TQ bisects angle RTP. Well, angle RTP is this angle right here. There's angle RTP. It says that TQ is bisecting that angle. What do bisectors do? Cut in half. So what does that mean about these two small angles that have a blue side and an orange side? They're congruent, yes. So this angle up here is the same size as this angle down here. The top angle is angle PTQ. And here in number 6, it says that that is 12x plus 4. So this would be 12x plus 4 degrees. Then it goes on to tell us that RTQ is 15x minus 5. RTQ is this one right here, 15x minus 5. They are congruent, so what do we do with their measurements? Set them equal. When things are the same, we set them equal. So when they're congruent, we're going to set them equal. Angle PTQ is congruent to angle RTQ. So the measurement of angle PTQ is equal to the measurement of angle RTQ. PTQ is 12x plus 4. RTQ is 15x minus 5. Thank you, Daniel. Once we have it set up like this, the first thing we're going to do is get our x's on the same side. So I'm going to minus 12x from both sides. What is 15 minus 12? 3. So I would have 4 equals 3x minus 5. Then I would add 5 to both sides. So that would give me 9 equals 3x. We would divide both sides by 3. What is 9 divided by 3? 3. So x is 3. What did they ask me to find in this problem, though? RTP. Find the measurement of angle RTP. RTP is this big one here in light blue. It's made up of two smaller angles put together. How do we put things together in math? We add them, yes. So the measurement of angle RTP is equal to the measurement of angle PTQ plus the measurement of angle RTQ. Angle PTQ was 12x plus 4, and PTQ was 15x minus 5. What can I do now? Substitute. The measurement of angle RTP is equal to 12 times 3 plus 4 plus 15 times 3 minus 5. All right, let's clean this up a little bit. What is 12 times 3? 36. And 36 plus 4 is what? 40. Plus, what is 15 times 3? 15 times 3? 45. Minus 5? 40. So how big is angle RTP? 80 degrees. Measurement of angle RTP is 80 degrees. Notice we got the exact same thing for angle PTQ and angle RTQ. We said they were congruent, so I'm not surprised that they came out to be the same number when we substituted in. We expect that to happen when they're congruent. What else would you guys like to see? Which one? 26? Absolutely, we can go to 26. Says angle R and angle T are complementary angles. So we learned about complementary and supplementary angles in this module. One of them adds up to 90 and the other one adds up to 180, and it's really important that we get this straight so that we don't set up our equations the wrong way. Here's the way I remember it. Which one comes first on the number line, 90 or 180? 90 would come first on the number line if we start from 0, right? Which one comes first in the alphabet, C or S? C. Complementary angles, the one that comes earlier in the alphabet, goes with the smaller number. So complementary angles is something plus something equals 90. If it comes later in the alphabet, then it goes with the bigger number. So supplementary goes with 180, complementary goes with 90. We know the names of these two angles. It's the measurement of angle R plus the measurement of angle T that are adding up to 90 degrees. And then it tells me right here, the measurement of angle R is 3x plus 12. So in the place of R, I'm going to put 3x plus 12. In the place of angle T, I'm going to put 2x minus 7. And that is equal to 90. Then we're going to combine our like terms together. 3x and 2x is going to combine to give me what? 5x. And then I have to combine my constants, my things that don't have variables. 12 and negative 7 combine to give me what? 5. So 5x plus 5 equals 90. Then we're going to subtract 5 from both sides. $90 minus 5 gives me 85. And then we divide both sides by 5. And that means x is what? X is 17. Did they ask me to find x? Yes, they did ask me to find x. So that's part of my answer. Is that all they asked me to find? No. What else do I need to find? The measurement of angle R and the measurement of angle T. So the measurement of angle R is 3x plus 12. We just figured out that x is 17, so I have 3 times 17 plus 12. What is 3 times 17 plus 12? 63. So the measurement of angle R is 63 degrees. The measurement of angle T is 2x minus 7. So the measurement of angle T is 2 times 17 minus 7. What is 2 times 17 minus 7? 27. And these two angles, because they are complementary, should add up to what? Should add up to 90. Do they add to 90? Does 63 and 27 add to 90? Yes. We have about 10 minutes left. That's enough time for 1 or 2 more problems, depending on how long they are. What else would you guys like to see? 27, and you wanted to see which one? Number 7? Let's look at 27 first, and then we'll go look at number 7. I think I have enough time for both. Number 27 says ray RS and ray RT are perpendicular. What does perpendicular mean again? Yes, means makes right angles. So I know what this needs to look like when I draw these two rays. It needs to look like this. And in the corner, I'm going to put a right angle marking. What's the name of the point in the corner? R. This has to be R because it's ray RS and ray RT, and this is the only point that's shared by both. So S has to be along one of the rays. T has to be along another ray. Says point V lies in the interior of angle SRT. So somewhere in the middle, we have a point V, and I'm going to draw a ray from R through V, creating two angles inside my right angle, two smaller angles. It says the measurement of angle SRV is 9J minus 44. So this is 9J minus 44 right here. And angle VRT is 6J plus 14. Find the value of J and angle SRV. Well, I know that the measurement of angle SRV plus the measurement of angle VRT is equal to the measurement of angle SRT. SRT is the big angle. The two smaller angles make the big angle. In the place of SRV, we're going to put 9J minus 44. In the place of VRT, we put 6J plus 14. And how big is angle SRT? 90. So I'm going to put 90 in for SRT. That is 90 degrees. All right. We're going to combine our like terms on the left-hand side. What is 9J plus 6J? 15J. And then we combine our constants, the things without variables. Negative 44 and positive 14 combines to give us what? Negative 30. So 15J minus 30 equals 90. Then we add 30 to both sides. So that would be 15J equals 120. Then we divide both sides by 15. What is 120 divided by 15? 8. So J is 8. And then we still need angle SRV. The measurement of angle SRV was 9J minus 44. So we have the measurement of angle SRV is 9 times 8 minus 44. What is 9 times 8 minus 44? 28. So angle SRV is 28 degrees. All right, we're going to go do problem number 7 next. This is on the front page. This one uses the exact same picture as number 6. So I'm going to redraw that picture so that we can mark it up with this new and different information. All right, so I have point S here, point T here, point P here, and then we have R and Q. It says that angle STR, this angle right here, is 102 degrees. We want to find the measurement of angle PTR first. That would be this angle. What is the name for the red and the blue angles there on the picture? What is the special angle pair name for that angle pair? What type of angles are those? They're a linear pair. They are adjacent, but they're more special than adjacent because their non-shared sides make a straight line. So angle STR and angle PTR are a linear pair. What's the relationship between linear pair angles? They add to 180 degrees. These are supplementary angles. These are supplementary angles. So the measurement of angle STR plus the measurement of angle PTR is equal to 180. Well, how big is angle STR? 102, so I have 102 degrees plus the measurement of angle PTR equals 180. Then I'm going to subtract 102 from both sides. What is 180 minus 102? 78. So angle PTR is 78 degrees. Way back at the beginning, before problem number 6, do you remember where it said TQ bisects RTP? This is RTP. TQ is bisecting that. What does it mean to bisect? To split in half. So what do I want to do with that measurement if I want just this angle? Divide it by 2, yes. The measure of angle QTR is equal to 78 degrees divided by 2. What is 78 divided by 2? 39. So angle QTR is 39 degrees. All right. Answer key can be found where? On Canvas. Where do you have to go to get to it? What button do you have to click first? Modules. And then once you click modules, what do you look for? Today's date. Go find today's date. It'll be listed underneath module 2, but you find today's date and you click on it. You go all the way to the bottom of the page. Down to the bottom of the page. The test review answer key is down here. You would click on it. It shows you the review with all of my work on there for you to follow along. You do have to turn in this test review tomorrow at the beginning of class before you take your test, so please make sure you finish this up tonight. Make sure you finish working through the test review tonight.